On August 26, 2023, a significant event occurred on the Moon involving the Vikram lander of Chandrayaan-3, which has been confirmed by ISRO, Indian Space Research Organization. Additionally, ISRO shared intriguing information via Twitter regarding the detection of hot plasma, sulfur, calcium, titanium, and even oxygen by Chandrayaan-3. However, when you visit ISRO's official website and delve into the details of these observations, you'll notice that ISRO has not yet disclosed the full implications of these discoveries for us and our everyday lives. This reticence might be due to ISRO considering it a preliminary assessment. But fear not, in this video, we aim to connect the dots among all the discoveries made by Chandrayaan-3 and draw practical conclusions. It's important to note that a lunar day on the Moon's south pole is only 14 days long. After this period, a lunar night follows, and Chandrayaan-3 will become inactive due to a lack of solar energy. Since 10 days have already passed, it's high time we explore the significance of these observations for people living on Earth. Our journey begins on August 26, when Prime Minister Modi officially named the landing site of Chandrayaan-3 as Shiv Shakti. This site is where Chandrayaan-3's moon lander successfully touched down, and henceforth, it will bear the name Shiv Shakti. Furthermore, August 23, the day Chandrayaan-3 landed, has been designated as our National Space Day, a moment of immense pride for all Indians. Indeed, this entire mission is a source of great pride for our nation. Therefore, we will meticulously analyze Chandrayaan-3's findings day by day and endeavor to make practical sense of them. Returning to August 23, the day of Vikram's landing, ISRO released a video that showcased a remarkable moment. As soon as Vikram lander touched down, it gracefully opened its door like a ramp, and the Pragyan rover emerged, unfolding its solar panel and leaving the lander. The subsequent day, August 24, didn't bring any new developments. All systems seemed to be functioning smoothly, suggesting this might have been a test phase. However, on August 25, something intriguing occurred. On August 25th, the rover was positioned approximately 8 meters away from the lander. This strategic placement allowed for a thorough assessment of all planned rover movements. It involved evaluating where it could go, the maximum distance it could cover, identification of potential obstacles to avoid, and monitoring the rover's adherence to these planned movements. Once this final test phase was successfully completed, both the lander and rover activated
all their instruments, including a device known as ILSA, which was installed on the lander. ILSA, an instrument designed for monitoring lunar seismic activity, was placed on the Moon's surface. As indicated, it functions as an exceptionally sensitive electrical version of the seismographs used to measure earthquakes on Earth. Unlike traditional seismographs that record data on paper, ILSA provides real-time and highly accurate online seismic activity data.
On August 26th, ISRO recorded a seismic activity graph indicating that lunar vibrations were captured. When highly sensitive instruments like ILSA record such graphs, there's a possibility that they may have picked up vibrations originating from the movement of a machine. In this case, what's intriguing is that these recorded vibrations from the rover, which ILSA captured on August 25th, just a day earlier, show a consistent positive reading of approximately 0.19 units. In contrast, another section of the graph records vibrations at around minus 0.1185 units, but only for a brief duration. Essentially, within just 3 days of commencing the mission, Chandrayaan-3 detected signs of seismic activity on the Moon, specifically moonquakes, distinct from earthquakes. Now, you might be wondering about the significance of identifying these minuscule moonquakes. However, It's important to note that these detected moonquakes can serve as crucial clues for future missions. They may help unravel the moon's history, shed light on its formation, and provide insights into internal lunar processes. These findings are invaluable for advancing our understanding of the moon's geological and geophysical characteristics. Let's move ahead to 27 August 2023. On this day, the Vikram lander's second instrument, known as Chandrayaan Surface Thermophysing Experiment, initiated the measurement of the moon's soil temperature. CHAST functions as a probe or detector equipped with 10 distinct thermal sensors, allowing it to detect and record even the most minor temperature fluctuations. Upon penetration of the moon's surface to a depth of just 10 km, CHAST yielded some remarkable observations. Initially, the temperature above the moon's surface registered at approximately 50 degrees Celsius. However, as the probe delved deeper beneath the surface, temperatures exhibited a dramatic decline. Astonishingly, at a depth of a mere 10 km, the temperature plummeted from 50 degrees Celsius to a chilling minus 10 degrees Celsius. This scenario is made possible when the moon's topsole acts as a thermal insulator, effectively shielding the lunar surface from the sun's direct penetration. To delve deeper into this aspect, we ventured onto ISRO's official website to uncover the elements that have been identified in the moon's soil thus far. What we discovered was precisely what we had anticipated, but we'll delve into that a bit later. For the time being, it's important to grasp that the findings related to temperature variations in the moon's topsole can have significant implications for potential moon colonization efforts. This is particularly relevant because the moon's surface temperature can plummet as low as minus 230 degrees Celsius. Hence, in the future, if we can manufacture bricks from lunar soil,
they could serve as effective insulators, preventing heat from escaping living quarters. Now, let's fast forward to August 28, when the Pragan rover initiated its survey of the moon's soil using its two advanced instruments. On August 28, 2023, one of Chandrayaan 3's instruments, LIBS, a laser-induced breakdown spectroscopy, transmitted an image to ISRO. This image revealed the presence of elements such as aluminum, sulfur, calcium, iron, chromium, titanium, manganese, silicon, and oxygen within the lunar soil. What's noteworthy is that the rover's other instrument, APSC's alpha-particle X-ray spectrometer, independently corroborated these observations. This particular aspect generated significant excitement surrounding Chandrayaan, prompting preparations for Chandrayaan-4 to be underway. ISRO's upcoming lunar mission, Chandrayaan-4 LUPEX, is a collaborative effort with the Japanese space agency JAXA, scheduled for launch around 2026. In this mission, ISRO will assist JAXA's rover in achieving a soft landing. The rover and launch vehicles sent to the moon will be provided by JAXA, while ISRO will manufacture the lander. LUPEX's primary focus will be on detecting traces of water at the moon's polar regions. Additionally, it aims to identify safe landing points for humans at the South Pole and assess survival conditions during lunar nights, which can become extremely cold, as I mentioned earlier. Consequently, the lander used in this mission will be smaller than the current Vikram lander. Furthermore, Chandrayaan-3's incomplete observations will be concluded by ISRO through this mission. However, there is a pertinent question: do Japanese scientists truly require ISRO's assistance? So to answer this, let's delve into the details of JAXA's Hayabusa mission. Firstly, the asteroid targeted in the Hayabusa mission is 5 times larger than the moon. Secondly, its size is approximately 11,000 times smaller than the moon. From a technical standpoint, landing on this asteroid was comparatively easier than landing on the moon, mainly due to the moon's stronger gravitational pull and shorter distance, making spacecraft deceleration more challenging.
As a result, Japan's moon mission, Hakuto or Mission 1, experienced a crash during landing on April 23. This is why ISRO's Vikram lander, which has demonstrated its reliability from launch to landing, will play a crucial role in LUPEX. However, ISRO planned a second soft landing mission for Vikram before initiating hibernation. Essentially, ISRO issued a command to Vikram for a second soft landing on September 4th. Vikram subsequently deployed a ramp for the chast, ILSA, and rover and retracted it inside after achieving a height of approximately 40 centimeters using its thrusters. After moving 40 centimeters away, it executed another soft landing, deploying its instruments and ramp. This demonstrates Vikram's precise control from launch to landing and its invaluable contributions to lunar research. ISRO is confident that Vikram and Pragyan will endure the lunar cold until the next lunar day on September 22nd. Even if they don't, they have already fulfilled their mission. Thanks for watching.